Picture this: a 20-story, tall mechanical monster weighing more than 47 Boeing 747s combined takes its final step across the scarred landscape of Ohio. Welcome to Never Built, where we explore the most ambitious technological failures, forgotten inventions, and utopian projects that crumbled before completion. I'm your host, and today we're diving into the story of the Silver Spade, a steel Goliath that literally reshaped our planet. But before we begin this incredible journey, make sure to subscribe to our channel and let me know in the comments what you think about these engineering marvels that time forgot. On a cold December morning in 2006, something extraordinary happened in southeastern Ohio. After 41 years of relentless operation, the Silver Spade, one of the largest walking dragline excavators ever built, took its final step. The machine that had moved more earth than any single piece of equipment in human history was about to become silent forever. The Silver Spade wasn't just a machine. It was a testament to an era when humanity believed that with enough steel, electricity, and engineering audacity, we could literally move mountains. And for 4 decades, that's exactly what it did. This colossal excavator, officially designated as the Bucyrus-Erie Model 1950B, stood 220 feet tall, taller than a 20-story building. Its boom stretched 410 feet into the sky, longer than a football field. But perhaps most impressive of all was its bucket, a steel maw capable of holding 80 cubic meters of earth and rock. To put that in perspective, you could park 2 full-size school buses inside that bucket with room to spare. The machine weighed an astounding 6,400 tons. That's more than the weight of 4,000 average cars, or roughly equivalent to a World War II battleship sitting on dry land. Yet despite this incredible mass, the Silver Spade could walk, not roll, not crawl, walk, using 4 massive hydraulic feet, each the size of a small house. It would lift its entire body and step forward, covering about 400 meters every hour. But what made the Silver Spade truly remarkable wasn't just its size. It was what it represented. This machine embodied the post-war American industrial optimism of the 1960s, when engineers believed that any problem could be solved by building something bigger, stronger, and more powerful than had ever been built before. What do you think? Was it pure ambition or a dance with destiny? Let me know in the comments. The Silver Spade was born from necessity. In the 1960s, America's appetite for electricity was growing at an unprecedented rate. Coal-fired power plants were being built across the nation, and they needed fuel, lots of it. The traditional method of underground coal mining was too slow and too dangerous to meet this demand. What was needed was a way to strip away the layers of earth above coal seams and extract the black gold beneath on an industrial scale. Enter the walking dragline excavator, a machine concept that seemed to defy logic. Instead of using tracks or wheels like conventional heavy equipment, these giants would literally walk across the landscape using hydraulic legs to lift and move their massive bodies. The idea was both brilliant and terrifying. Create a machine so large that it could remove entire hillsides in a matter of months. The Silver Spade was the pinnacle of this technology. When it began operations in 1965 at the Muskingum Mine in Ohio, it was the largest mobile land machine ever constructed. Its very existence challenged our understanding of what was mechanically possible. The machine operated on 13,800 volts of electricity, drawing power through a cable as thick as a human thigh. This electrical umbilical cord connected the Silver Spade to the power grid, feeding it enough electricity to power a city of 10,000 people. The machine consumed power at such a rate that its operation had to be coordinated with the local electrical utility to prevent brownouts in surrounding communities. From its air-conditioned control cab, a technological marvel in itself for the 1960s, a single operator could control this mechanical leviathan. Using just 2 joysticks, one person could make the Silver Spade walk, swing its boom, lower its bucket, and lift 140 tons of earth in a single bite. The precision required was extraordinary. Despite its massive size, operators could pick up a single rock or delicately maneuver around obstacles. The psychological impact of the Silver Spade was as significant as its physical presence. Workers at the mine described feeling dwarfed by the machine, like ants working alongside a mechanical god. The sound it made, a deep, resonant hum punctuated by the hydraulic hiss of its walking mechanism, could be heard for miles. Local residents set their clocks by its operations, knowing that the machine worked around the clock, 365 days a year. But the Silver Spade was more than just a machine. It was a symbol of humanity's relationship with the natural world during the Industrial Age. This was an era when environmental concerns took a backseat to economic progress, when the phrase "man versus nature" wasn't just a metaphor. It was a daily reality played out on an epic scale. The story of the Silver Spade begins not in the coalfields of Ohio, but in the boardrooms and engineering offices of post-war America, where ambitious men dreamed of machines that could reshape the very earth beneath our feet. In 1962, the Hanna Coal Company faced a problem that seemed insurmountable. They had acquired mining rights to vast coal deposits in southeastern Ohio, but these deposits lay beneath hundreds of feet of overburden, layers of soil, rock, and clay that had accumulated over millions of years. Traditional mining methods would take decades to access these coal seams, and time was money in the rapidly expanding energy market of the 1960s. The solution came from an unlikely source: the Bucyrus-Erie Company, a manufacturer of heavy equipment based in Wisconsin. Bucyrus-Erie had been building steam shovels and excavators since the late 1800s, but they had never attempted anything on the scale that Hanna Coal was proposing. The specifications were staggering. Hanna Coal wanted a machine that could remove overburden at a rate of 24 million cubic yards per year, enough earth to bury the entire island of Manhattan under 6 feet of soil. The machine would need to operate continuously, 24 hours a day, 7 days a week, in all weather conditions. It would need to be mobile enough to follow the coal seams as mining progressed, yet stable enough to handle loads that would crush conventional equipment. The engineering challenge was unprecedented. No one had ever built a walking machine of this size. The largest dragline excavators of the era weighed around 2,000 tons. Impressive, but nowhere near the 6,400 tons that the Silver Spade would eventually weigh. The physics alone seemed to argue against the project's feasibility. Leading the engineering team was a brilliant but eccentric engineer named Robert Kress. Kress had spent his career pushing the boundaries of heavy equipment design, but even he was daunted by the scope of the Silver Spade project. The machine would need to walk on 4 legs, each capable of supporting over 1,600 tons while maintaining stability on uneven terrain. The hydraulic systems required to accomplish this feat would need to operate at pressures never before attempted in mobile equipment. The boom, the long arm that would support the bucket, presented its own set of challenges. At 410 feet in length, it would be longer than most skyscrapers were tall. The structural stresses involved in swinging such a massive arm while supporting a 140-ton load were mind-boggling. Traditional steel construction techniques simply weren't adequate for the task. Kress and his team spent 2 years developing new welding techniques, new steel alloys, and entirely new approaches to hydraulic engineering. They built scale models, conducted stress tests, and ran computer simulations on some of the most advanced computers available in the mid-1960s. Every component had to be designed from scratch, as nothing of this scale had ever been attempted before. The construction of the Silver Spade began in 1963 at a specially built facility in Ohio. The machine was too large to be transported by conventional means, so it had to be assembled on site. The construction process itself was a marvel of logistics and engineering. Massive cranes were brought in to lift components weighing hundreds of tons into place. Specialized welding crews worked around the clock to join the massive steel sections that would form the machine's superstructure. The walking mechanism was perhaps the most innovative aspect of the entire design. Each of the Silver Spade's 4 feet was a masterpiece of hydraulic engineering, containing cylinders capable of generating over 2 million pounds of lifting force. The feet themselves were circular pads 22 feet in diameter, designed to distribute the machine's enormous weight over a large area to prevent it from sinking into the ground. The electrical systems were equally impressive. The machine required its own substation to step down the high-voltage power from the grid to the various voltages needed by different systems. Miles of heavy-duty cable snaked through the machine's superstructure, connecting everything from the massive drive motors to the delicate control systems in the operator's cab. Can you imagine the audacity it took to even conceive of such a machine? What do you think drove these engineers to push so far beyond the limits of known technology? Share your thoughts in the comments below. The control system was revolutionary for its time. In an era when most heavy equipment was controlled by mechanical levers and cables, the Silver Spade featured an electronic control system that allowed a single operator to manage the machine's complex operations. The operator's cab was pressurized and air-conditioned, luxuries that were almost unheard of in industrial equipment of the 1960s. But perhaps the most remarkable aspect of the Silver Spade's construction was the sheer audacity of the project. In 1963, computer-aided design didn't exist. Finite element analysis was in its infancy. The engineers working on the Silver Spade had to rely on slide rules, mechanical calculators, and their own intuition to design a machine that pushed the boundaries of physics and engineering. The first test of the Silver Spade's walking mechanism took place on a cold morning in November 1964. Engineers, executives, and curious onlookers gathered to watch as the massive machine attempted its first step. The hydraulic pumps whined to life, pressure built in the system, and slowly, almost imperceptibly at first, the Silver Spade lifted one of its massive feet and moved it forward 18 inches. The crowd erupted in cheers. They had just witnessed something that had never been done before. A 6,400-ton machine had walked. It was a moment that would be remembered as one of the greatest achievements in the history of heavy equipment engineering. But the real test was yet to come. Walking a few steps in a controlled environment was one thing. Operating continuously in the harsh conditions of a coal mine was another entirely. The Silver Spade would need to prove itself capable of the relentless, punishing work for which it had been designed. The machine's first operational deployment came in early 1965 at the Muskingum mine. The sight of the Silver Spade arriving at the mine site was unforgettable. Local residents lined the roads to watch as the mechanical giant slowly walked to its new home, each step taking several minutes to complete. Children pointed in amazement, adults shook their heads in disbelief, and everyone understood that they were witnessing something unprecedented in human history. The Silver Spade represented more than just an engineering achievement. It embodied the optimism and ambition of an era when Americans believed that technology could solve any problem, overcome any obstacle, and reshape the world according to human will. It was a time when bigger was always better, when the phrase "impossible" was seen as a challenge rather than a limitation. As the Silver Spade took its position at the Muskingum mine and prepared to begin its decades-long mission of moving mountains, no one could have predicted that they were witnessing not just the birth of a machine, but the beginning of an era that would fundamentally change humanity's relationship with the natural world. To understand the true magnitude of the Silver Spade's engineering achievement, we need to dive deep into the technical innovations that made this mechanical leviathan possible. What the engineers at Bucyrus-Erie accomplished in the mid-1960s was nothing short of revolutionary. They essentially invented an entirely new category of machine. The heart of the Silver Spade was its walking mechanism, a system so complex and innovative that it required the development of entirely new hydraulic technologies. Traditional excavators used tracks or wheels for mobility, but at the Silver Spade's massive scale, these conventional methods would have been inadequate. The The ground pressure from a 6,400-ton tracked vehicle would have been so enormous that it would have sunk into all but the most solid rock. The solution was the walking system, 4 massive hydraulic legs that could lift the entire machine and move it forward in a carefully choreographed sequence. Each leg consisted of a massive hydraulic cylinder capable of generating over 2 million pounds of force. To put this in perspective, that's enough force to lift a fully loaded Boeing 747 aircraft. The walking sequence itself was a marvel of engineering precision. The Silver Spade would begin by shifting its weight to its rear legs, then lift its front legs and move them forward. The machine would then shift its weight forward and repeat the process with its rear legs. Each complete walking cycle moved the machine forward approximately 18 inches and took about 15 minutes to complete. The hydraulic system required to power this walking mechanism was unprecedented in its complexity. The machine used over 3,000 gallons of hydraulic fluid, circulated through a network of pipes and hoses that, if laid end to end, would stretch for over 5 miles. The hydraulic pumps were driven by electric motors, generating a combined 4,000 horsepower, more power than most locomotives of the era. But the walking mechanism was just one of many engineering challenges that had to be overcome. The boom, the massive arm that supported the bucket, was a structural engineering marvel in its own right. At 410 feet in length, it was longer than a football field and had to support loads of up to 140 tons while remaining stable enough for precise operation. The boom was constructed using a revolutionary lattice design that maximized strength while minimizing weight. The steel framework was made from specially developed high-strength alloys that were stronger and lighter than conventional structural steel. Even so, the boom alone weighed over 800 tons, more than most entire excavators of the era. The bucket presented its own set of engineering challenges. With a capacity of 80 cubic meters, it was large enough to hold 2 school buses, yet it had to be light enough to be lifted by the boom and strong enough to bite through solid rock. The bucket was constructed using a combination of high-strength steel and innovative design techniques that distributed stress loads throughout the structure. The cutting edge of the bucket was fitted with replaceable teeth made from specially hardened steel alloys. These teeth had to be sharp enough to cut through rock and clay, yet durable enough to last for months of continuous operation. The forces involved in the cutting process were enormous. When the Silver Spade bit into solid rock, the impact forces could exceed 1 million pounds. Think about this for a moment. Engineers in the 1960s, working with slide rules and mechanical calculators, designed a machine that could generate forces measured in millions of pounds. What does this say about human ingenuity and determination? I'd love to hear your thoughts in the comments. The electrical systems of the Silver Spade were equally impressive. The machine operated on 13,800 volts of electricity, a voltage level typically used for power transmission lines, not mobile equipment. This high voltage was necessary to provide the enormous amounts of power required by the machine's various systems while minimizing the size and weight of the electrical cables. The power was delivered to the Silver Spade through a trailing cable that was over 2 inches in diameter and weighed more than 10 pounds per foot. This cable had to be flexible enough to allow the machine to move, yet robust enough to carry the massive electrical loads without overheating or failing. Special cable handling equipment was developed to manage this electrical umbilical cord as the machine walked across the mining site. Inside the Silver Spade, the electrical power was distributed through a complex network of transformers, switchgear, and control systems. The machine contained its own electrical substation, complete with circuit breakers, protective relays, and monitoring equipment. The electrical room of the Silver Spade looked more like the control room of a power plant than the interior of a mobile machine. The control system was revolutionary for its time. In the 1960s, most heavy equipment was controlled using mechanical linkages, cables, and levers. The Silver Spade, however, featured an electronic control system that used early solid-state electronics to manage the machine's complex operations. The operator's controls consisted of just two joysticks, yet through the electronic control system, these simple inputs could coordinate the movements of dozens of hydraulic cylinders and electric motors. The operator's cab itself was a technological marvel. Suspended within the machine's superstructure on shock absorbers, the cab was designed to isolate the operator from the vibrations and movements of the massive machine. The cab was pressurized to keep out dust and fumes, and it featured air conditioning, a luxury that was almost unheard of in industrial equipment of the era. The cab's windows were made from specially treated glass that could withstand the impact of flying rocks and debris. The operator's seat was custom designed to provide comfort during the long shifts required for continuous operation. Instrumentation panels displayed information about every aspect of the machine's operation, from hydraulic pressures to electrical loads to the position of the boom and bucket. Perhaps most impressive of all was the precision with which the Silver Spade could operate despite its enormous size. The electronic control system allowed operators to perform delicate operations such as picking up a single rock or carefully maneuvering around obstacles. The machine's movements could be controlled to within inches, despite the fact that the bucket was suspended at the end of a 410-foot boom. The engineering innovations developed for the Silver Spade had impacts far beyond the mining industry. The hydraulic technologies developed for the walking system were later adapted for use in construction equipment, manufacturing machinery, and even aerospace applications. The electronic control systems pioneered on the Silver Spade became the foundation for the computer-controlled heavy equipment that is standard today. The materials science advances required for the Silver Spade's construction led to the development of new steel alloys and welding techniques that found applications in everything from skyscrapers to bridges to ships. The electrical systems developed for the machine contributed to advances in high-voltage power distribution and motor control technology. But perhaps the most significant impact of the Silver Spade's engineering was psychological. The machine proved that with enough determination, creativity, and engineering skill, humans could build machines of almost unimaginable size and capability. It demonstrated that the limits of what was possible were not fixed, but could be pushed ever further through innovation and audacity. The Silver Spade represented the pinnacle of 1960s engineering optimism, the belief that any problem could be solved by building something bigger, stronger, and more powerful than had ever been built before. It was a philosophy that would define an entire era of American industrial development, and the Silver Spade was its most magnificent expression. Watching the Silver Spade in operation was like witnessing a scene from science fiction. This 6,400-ton mechanical giant would slowly lift one of its massive feet, pause for a moment as hydraulic systems adjusted and balanced, then deliberately place it down 18 inches forward. The ground would shake with each step, and the deep rumble of hydraulic pumps and electric motors would echo across the mining site like the heartbeat of some mechanical god. The walking process was both mesmerizing and terrifying to observe. Each foot was a circular pad 22 feet in diameter, large enough to serve as a small house foundation. When the Silver Spade lifted a foot, it revealed the massive circular impression left in the earth, a permanent scar that marked the passage of this industrial leviathan. The machine's walking speed was deliberately slow, approximately 400 meters per hour, or about the pace of a leisurely human stroll. This wasn't due to any limitation in the hydraulic systems, but rather a careful balance between mobility and stability. At 6,400 tons, the Silver Spade couldn't afford to make any sudden movements. Every step had to be calculated, every weight shift carefully managed to prevent the machine from losing its balance and toppling over. The sight of the Silver Spade walking across the landscape was both awe-inspiring and unsettling. Local residents would drive from miles away just to watch the machine move, bringing their families to witness something that seemed to defy the natural order. Children would point in amazement as the mechanical giant slowly made its way across the mining site, its massive boom swaying gently with each step. But the Silver Spade's true purpose wasn't walking. It was the systematic removal of overburden to expose the coal seams beneath. The machine's operational cycle was a carefully choreographed dance of mechanical precision that could remove over 100,000 tons of earth in a single day. The process began with the positioning of the machine. Using its walking capability, the Silver Spade would move to the optimal location for the next dig. The operator, sitting in the air-conditioned cab 200 feet above the ground, would use the machine's sophisticated positioning systems to align the boom and bucket with surgical precision. The actual digging process was a marvel of controlled violence. The massive bucket, weighing 40 tons even when empty, would be lowered to the earth and driven forward into the overburden. The cutting teeth, each weighing several hundred pounds, would bite into rock and soil with forces measured in millions of pounds. The sound was indescribable, a combination of grinding, crushing, and tearing that could be heard for miles. Once the bucket was full, holding up to 140 tons of material, the real show began. The boom would slowly lift the massive load, raising it 200 feet into the air before swinging it to the side and depositing the overburden in a carefully planned spoil pile. The entire cycle, from digging to dumping, took approximately 2 minutes and removed enough earth to fill several dump trucks. The precision required for this operation was extraordinary. Despite the massive scale of the machine and the enormous forces involved, operators could control the Silver Spade's movements to within inches. They could delicately pick up a single rock, carefully maneuver around obstacles, or precisely place material in specific locations. This level of control was achieved through the machine's revolutionary electronic control system, which translated the operator's joystick movements into coordinated actions by dozens of hydraulic cylinders and electric motors. Engagement prompt. Imagine being the operator of such a machine, controlling forces that could literally move mountains with just 2 joysticks. What kind of person do you think it took to handle such responsibility? Let me know what you think in the comments. The psychological impact of operating the Silver Spade was profound. Operators described feeling like gods, wielding power over the landscape that was almost incomprehensible. From their perch high above the mining site, they could reshape the earth with simple movements of their hands. Hills that had stood for millions of years could be leveled in a matter of days. Valleys could be filled, ridges could be created, and the very topography of the region could be altered according to human will. But this godlike power came with enormous responsibility. A single mistake by an operator could result in catastrophic damage to the machine or injury to workers on the ground. The forces involved were so enormous that even minor errors could have major consequences. Operators underwent extensive training and had to demonstrate not just technical competence, but also the psychological stability to handle such awesome responsibility. The Silver Spade operated 24 hours a day, 7 days a week, 365 days a year. The machine never truly rested. When one shift ended, another began immediately. Maintenance was performed on the fly, with crews working around the clock to keep the mechanical giant operational. The economic pressure to keep the Silver Spade running was enormous. Every hour of downtime cost thousands of dollars in lost production. The machine's appetite for electricity was as voracious as its appetite for earth. The Silver Spade consumed power at a rate of approximately 8 megawatts. Enough electricity to power a small city. The local electrical utility had to upgrade their transmission lines and substations to handle the massive electrical load. During peak operations, the Silver Spade's power consumption could cause voltage fluctuations that affected the entire regional electrical grid. The environmental impact of the Silver Spade's operations was staggering. In a single year, the machine could remove over 24 million cubic yards of overburden, enough earth to bury the entire island of Manhattan under 6 feet of soil. The landscape around the Muskingum mine was completely transformed by the Silver Spade's operations, with entire hills disappearing and new topographical features being created. The spoil piles created by the Silver Spade were artificial mountains in their own right. Some reached heights of over 300 feet and covered areas of several square miles. These man-made mountains became permanent features of the landscape, visible from space and destined to remain long after the coal beneath them had been exhausted. The machine's impact extended far beyond the immediate mining site. The vibrations from the Silver Spade's operations could be felt for miles, and the sound of its hydraulic systems became a constant background noise for residents of the surrounding area. Some people complained of the noise and vibrations, while others found them oddly comforting, a reminder of the industrial might that provided jobs and economic prosperity to the region. Wildlife in the area was profoundly affected by the Silver Spade's presence. The machine's operations destroyed existing habitats and created new ones, fundamentally altering the local ecosystem. Some species fled the area, while others adapted to the changed environment. The spoil piles eventually became home to new plant and animal communities, creating artificial ecosystems that had never existed before. The Silver Spade became more than just a machine. It became a symbol of human dominance over nature. For the workers at the mine, it represented job security and economic opportunity. For the local community, it was a source of pride and identity. For environmentalists, it became a symbol of industrial excess and environmental destruction. For engineers and technology enthusiasts, it represented the pinnacle of human achievement in heavy machinery design. But perhaps most significantly, the Silver Spade represented a particular moment in history. A time when Americans believed that technology could solve any problem, overcome any obstacle, and reshape the world according to human desires. It was an era of unprecedented optimism about the power of engineering and the limitless potential of human ingenuity. As the Silver Spade continued its relentless work, day after day, year after year, it became clear that this machine was more than just a tool for mining coal. It was a testament to human ambition, a monument to engineering achievement, and a symbol of an era when the impossible was just another engineering challenge waiting to be solved. Operating. The Silver Spade required a special breed of individual, someone who could handle the psychological pressure of controlling a 6,400-ton machine while maintaining the precision necessary to perform delicate operations with equipment that could accidentally demolish a building. The men who became Silver Spade operators were part pilot, part surgeon, and part artist, wielding mechanical power that dwarfed anything else on Earth. The selection process for Silver Spade operators was rigorous and unforgiving. Candidates had to demonstrate not just technical competence with heavy machinery, but also the psychological stability to handle the enormous responsibility that came with the job. A single mistake could result in millions of dollars in damage to the machine, injury or death to workers on the ground, or catastrophic environmental damage. Training to operate the Silver Spade took over 6 months and was unlike anything else in the heavy equipment industry. New operators started by learning the machine systems in exhaustive detail. Every hydraulic circuit, every electrical component, every safety system. They had to understand not just how to operate the machine, but how it worked at the most fundamental level. The training program included extensive simulator work using scale models and eventually graduated to supervised operation of the actual machine. Trainees spent hundreds of hours learning to coordinate the complex movements required to operate the Silver Spade effectively. They had to master the art of walking the machine, learning to feel the subtle shifts in balance and weight distribution that indicated whether the next step would be safe. But technical competence was only part of what made a successful Silver Spade operator. The job required an almost superhuman level of concentration and situational awareness. Operators had to simultaneously monitor dozens of instruments, coordinate multiple mechanical systems, and maintain awareness of workers and equipment on the ground hundreds of feet below. The psychological demands of the job were enormous. Operators worked 12-hour shifts in the machine's cab, 200 feet above the ground, surrounded by the constant noise and vibration of the massive machine. The isolation was profound. During operations, the operator was essentially alone with the machine, responsible for making split-second decisions that could have far-reaching consequences. Many operators described an almost mystical relationship with the Silver Spade. After months or years of operation, they claimed to be able to feel the machine's moods, to sense when something wasn't quite right with its systems, to predict mechanical problems before they occurred. They spoke of the machine as if it were a living creature with its own personality and temperament. The most skilled operators could make the Silver Spade perform feats that seemed impossible given its massive size. They could delicately pick up a single rock without disturbing the surrounding soil, thread the bucket through narrow spaces with inches to spare, or stack materials with the precision of a master craftsman. These operators became legends within the mining industry, their skills talked about with reverence and awe. One such operator was James "Big Jim" Morrison, who operated the Silver Spade for over 15 years and became something of a folk hero in the mining community. Morrison was known for his ability to make the massive machine perform with ballet-like grace, executing complex maneuvers that other operators wouldn't even attempt. He could walk the Silver Spade across terrain that seemed impossible for such a massive machine, carefully placing each foot to avoid obstacles or unstable ground. Morrison's most famous feat occurred during a particularly challenging operation, when the Silver Spade needed to remove overburden from around a natural gas pipeline that couldn't be relocated. Working with surgical precision, Morrison used the machine's massive bucket to carefully excavate around the pipeline, removing thousands of tons of earth while never coming closer than 6 inches to the pressurized gas line. The operation took 3 days and was watched by engineers and safety officials who were convinced that disaster was inevitable. But Morrison's skill with the machine was so complete that he completed the operation without incident, earning him legendary status among his peers. Can you imagine the nerves of steel it must have taken to perform such precise work with a machine of this scale? What do you think separated the great operators from the merely competent ones? Share your thoughts below. The operators developed their own culture and traditions around the Silver Spade. They had their own slang, their own rituals, and their own unwritten rules about how the machine should be treated. New operators were inducted into this culture through a combination of formal training and informal mentorship by veteran operators who passed down not just technical knowledge, but also the wisdom and intuition that came from years of working with the machine. The relationship between operators and maintenance crews was crucial to the Silver Spade's success. The machine operated continuously, which meant that maintenance had to be performed while it was running. This required extraordinary coordination between operators and maintenance personnel, with operators having to position the machine and shut down specific systems to allow maintenance work to proceed safely. Maintenance crews developed their own expertise and culture around the Silver Spade. These were the people who kept the mechanical giant running, working in conditions that were often dangerous and always challenging. They had to climb hundreds of feet into the machine's superstructure, work with hydraulic systems operating at enormous pressures, and handle electrical systems that could kill instantly if mishandled. The maintenance crews took enormous pride in their work, knowing that the entire mining operation depended on their ability to keep the Silver Spade operational. They developed innovative techniques for maintaining and repairing systems that had never existed before, often having to invent solutions to problems that no one had ever encountered. The social dynamics around the Silver Spade were complex and fascinating. The machine became the center of a community that included not just operators and maintenance crews, but also engineers, supervisors, support staff, and their families. The success or failure of the Silver Spade affected everyone in the community, creating a shared sense of purpose and identity. Operators were treated with a respect that bordered on reverence. They were the elite of the mining workforce, earning significantly higher wages than other workers and enjoying a status that extended beyond the workplace into the broader community. Children would point them out on the street, and local newspapers would feature stories about their achievements and adventures. But the job also took its toll. The stress of operating such a massive and potentially dangerous machine, combined with the long hours and demanding working conditions, led to high rates of burnout and health problems among operators. Many developed chronic back problems from sitting in the operator's seat for 12 hours at a time. Others suffered from stress-related illnesses caused by the constant pressure of the job. The psychological impact of controlling such enormous power was profound and sometimes troubling. Some operators became addicted to the feeling of godlike control over the landscape, struggling to adjust to normal life when they weren't operating the machine. Others became obsessed with the machine itself, spending their off hours studying its systems and thinking about ways to improve its performance. Despite these challenges, most Silver Spade operators considered their job to be the pinnacle of their careers. They had been chosen to operate the largest mobile land machine ever built, to wield power that was literally earth-moving, and to be part of an engineering achievement that would be remembered long after they were gone. The operators understood that they were not just doing a job, they were participating in history. They were the human interface with a machine that represented the pinnacle of 1960s engineering achievement, the embodiment of an era's belief in the unlimited potential of technology and human ingenuity. As the Silver Spade continued its relentless work year after year, the operators who controlled it became part of its legend. They were the human element in a story of mechanical achievement, the skilled craftsmen who could make a 6,400-ton machine dance to their will, the masters of a mechanical giant that had redefined what was possible in the realm of heavy equipment engineering. By the 1980s, the Silver Spade had been operating for nearly 2 decades, and its impact on the landscape of southeastern Ohio was nothing short of apocalyptic. What had once been rolling hills covered with forests and farmland had been transformed into an alien landscape of massive spoil piles, artificial lakes, and geometric patterns that could be seen from space. The environmental cost of the Silver Spade's operations was staggering. In 20 years of operation, the machine had moved over 400 million cubic yards of overburden, enough earth to bury the entire state of Rhode Island under 3 feet of soil. Entire ecosystems had been obliterated, replaced by artificial landscapes that bore no resemblance to what had existed before. The machine's appetite for destruction seemed insatiable. Ancient forests that had stood for centuries were cleared in a matter of days. Streams and rivers were diverted or buried under millions of tons of spoil. Wildlife populations were displaced or destroyed, their habitats erased as thoroughly as if they had never existed. But the environmental impact was just one aspect of the price paid for the Silver Spade's operations. The social and cultural costs were equally profound, though less immediately visible. Rural communities that had existed for generations were displaced to make way for mining operations. Family farms that had been passed down through multiple generations were sold to mining companies and disappeared under the machine's relentless advance. The people who lived in the path of the Silver Spade faced an impossible choice: accept the mining company's offer to buy their property, or watch as their neighbors sold out and their community disintegrated around them. Most chose to sell, taking the money and moving elsewhere. But the psychological cost of leaving ancestral lands was enormous. Those who stayed found their lives fundamentally altered by the presence of the Silver Spade. The machine operated 24 hours a day, 7 days a week, filling the air with constant noise and vibration. Dust from the mining operations coated everything within miles of the site. The heavy truck traffic required to support the operation turned quiet country roads into industrial highways. The health impacts of living near the Silver Spade's operations were significant and long-lasting. Residents reported increased rates of respiratory problems, likely caused by the constant dust in the air. The noise and vibration from the machine's operations disrupted sleep patterns and caused stress-related health problems. Some residents claimed that the vibrations from the Silver Spade's walking mechanism caused structural damage to their homes. But perhaps the most profound impact was psychological. The presence of the Silver Spade represented a fundamental shift in the relationship between humans and the natural world. For generations, the people of southeastern Ohio had lived in harmony with the landscape, adapting their lives to the rhythms of the seasons and the contours of the land. The Silver Spade represented the opposite philosophy, the belief that the natural world should be reshaped to serve human needs, regardless of the cost. This raises a fundamental question about progress and its costs. Was the energy security and economic prosperity provided by the Silver Spade worth the environmental and social destruction it caused? What do you think? Let me know in the comments. The economic benefits of the Silver Spade's operations were undeniable. The machine enabled the extraction of millions of tons of coal that provided electricity to power American industry and homes. The mining operations provided hundreds of well-paying jobs in a region that had few other economic opportunities. The taxes paid by the mining company supported local schools, roads, and public services. But even the economic benefits came with hidden costs. The jobs provided by the mining operation were temporary. Once the coal was exhausted, the jobs would disappear, leaving behind a landscape that was unsuitable for most other economic activities. The tax revenue from mining operations was substantial in the short term, but it came at the expense of other potential economic activities, such as agriculture, forestry, and tourism, that could have provided sustainable long-term income. The true environmental cost of the Silver Spade's operations became apparent only gradually, as scientists began to understand the long-term impacts of large-scale surface mining. The removal of topsoil and vegetation disrupted natural water cycles, leading to increased erosion and flooding. The exposure of sulfur-bearing rocks to air and water created acid mine drainage, which contaminated streams and groundwater for miles around the mining site. The massive spoil piles created by the Silver Spade were unstable and prone to landslides, particularly during heavy rains. Several serious accidents occurred when spoil piles collapsed, damaging property and threatening lives. The artificial lakes created by mining operations were often contaminated with heavy metals and other toxic substances, making them unsuitable for recreation or wildlife habitat. Perhaps most troubling was the realization that many of the environmental impacts of the Silver Spade's operations were irreversible. The complex ecosystems that had been destroyed could not be recreated, even with the most sophisticated restoration techniques. The topsoil that had taken thousands of years to develop was gone forever, buried under millions of tons of spoil or eroded away by wind and water. As environmental awareness grew in the 1970s and 80s, the Silver Spade became a symbol of industrial excess and environmental destruction. Environmental activists organized protests at the mining site, demanding stricter regulations on surface mining operations. Scientists studied the long-term impacts of the machine's operations, documenting the extent of environmental damage and the challenges of restoration. The mining company responded to these criticisms by implementing new environmental protection measures and restoration programs. They began replanting vegetation on completed mining areas and treating acid mine drainage to reduce water pollution. But these efforts, while well-intentioned, could not undo the fundamental transformation of the landscape that had already occurred. The regulatory environment around surface mining began to change in response to growing environmental concerns. New laws required mining companies to obtain more detailed environmental permits, conduct more extensive environmental impact assessments, and provide more comprehensive restoration plans. These regulations increased the cost and complexity of mining operations, making projects like the Silver Spade more difficult to justify economically. The changing economics of coal mining also began to affect the Silver Spade's operations. Competition from natural gas and other energy sources reduced demand for coal, while environmental regulations increased the cost of coal-fired electricity generation. The easy-to-reach coal seams that had made the Silver Spade's operations so profitable were becoming exhausted, forcing the machine to work in more challenging and less profitable areas. By the 1990s, it was becoming clear that the Silver Spade represented not just a particular approach to mining, but a particular era in American industrial development. The machine had been conceived and built during a time when environmental concerns were secondary to economic growth, when the belief in technological progress was unquestioned, and when the idea that natural resources were limitless still seemed plausible. The Silver Spade had fulfilled its original mission spectacularly, extracting hundreds of millions of tons of coal and generating billions of dollars in economic value. But the true cost of this achievement was only beginning to be understood. The machine had not just moved mountains, it had fundamentally altered the relationship between humans and the natural world, demonstrating both the awesome power of human technology and its potential for unintended consequences. As the 20th century drew to a close, the Silver Spade continued its relentless work, but the world around it was changing. The era of unlimited faith in technological progress was ending, replaced by a more nuanced understanding of the complex relationships between technology, society, and the environment. The machine that had once been celebrated as the pinnacle of human achievement was increasingly seen as a symbol of an approach to progress that was no longer sustainable. December 15, 2006. After 41 years of continuous operation, after moving more Earth than any single machine in human history, the Silver Spade took its final step. The end came not with a dramatic failure or catastrophic breakdown, but with the quiet recognition that an era had passed. The economics of coal mining had changed, environmental regulations had tightened, and the easy coal that had justified the Silver Spade's existence was nearly exhausted. The machine that had once seemed like the future of mining had become a relic of the past. The decision to retire the Silver Spade was not made lightly. The machine was still mechanically sound, still capable of the earth-moving feats that had made it famous. But the world had changed around it. Natural gas had become cheaper and cleaner than coal for electricity generation. Renewable energy sources were becoming increasingly competitive. The environmental costs of surface mining were no longer acceptable to regulators or the public. The final months of the Silver Spade's operation were bittersweet. Workers who had spent their entire careers with the machine knew that they were witnessing the end of something extraordinary. Operators who had mastered the art of controlling the 6,400-ton giant prepared to say goodbye to the machine that had defined their professional lives. James Morrison, the legendary operator who had worked with the Silver Spade for over 15 years, was chosen to perform the machine's final operation. On that cold December morning, Morrison climbed the stairs to the operator's cab for the last time, settling into the seat where he had spent thousands of hours over the years. The final dig was ceremonial rather than practical, a symbolic gesture to mark the end of an era. Morrison lowered the massive bucket to the earth one last time, filled it with Ohio soil, and lifted the 140-ton load high into the air. For a moment, the Silver Spade stood motionless, its boom extended against the gray winter sky, holding its final bite of earth like an offering to the gods of industry. Then, slowly and deliberately, Morrison swung the boom to the side and deposited the load on the spoil pile that the Silver Spade had been building for 4 decades. The hydraulic systems sighed to a stop. The electric motors fell silent, and the mechanical giant that had reshaped the landscape of southeastern Ohio was still forever. The silence was profound and unsettling. For 41 years, the sound of the Silver Spade's operations had been a constant presence in the region. The deep hum of hydraulic pumps, the whine of electric motors, the rumble of the walking mechanism. Local residents had set their clocks by the machine's operations, and children had grown up with its mechanical heartbeat as the soundtrack of their lives. Now, suddenly, it was quiet. The absence of sound was as dramatic as the machine's presence had been. Workers stood in small groups, talking in hushed tones, as if they were attending a funeral. In many ways, they were. They were witnessing the death of a machine, but also the end of an era of American industrial optimism. The question of what to do with the Silver Spade after its retirement sparked intense debate. Some proposed moving the machine to a museum where it could be preserved as a monument to American engineering achievement. Others suggested dismantling it for scrap, arguing that the steel could be recycled for more productive uses. Environmental groups called for the machine to be left in place as a reminder of the environmental costs of industrial progress. In the end, economics made the decision. The cost of moving the Silver Spade was prohibitive. The machine was simply too large and too heavy to be transported by conventional means. Dismantling it would have required specialized equipment and techniques that would have cost millions of dollars. The mining company chose the most practical option. The Silver Spade would be partially dismantled and buried in place. Think about this irony. A machine that had spent its entire existence moving Earth was ultimately buried by the Earth it had moved. What does this say about the relationship between human ambition and the natural world? I'd love to hear your reflections in the comments. The dismantling of the Silver Spade was a complex and emotional process. Crews carefully removed valuable components, the electric motors, hydraulic pumps, and control systems that could be salvaged and reused. The massive boom was cut into sections and lowered to the ground. The operator's cab, where so many skilled operators had spent their careers, was carefully removed and donated to a local museum. But the main body of the machine, the massive superstructure that had housed the walking mechanism and supported the boom, was too large and too expensive to remove. Instead, it was partially buried in place, covered with millions of tons of the same overburden that the Silver Spade had spent 4 decades moving. The burial of the Silver Spade was perhaps the most poetic moment in the machine's long history. The earth that it had displaced, the soil and rock that it had moved from place to place in its relentless quest for coal, was returned to cover the machine itself. The Silver Spade, which had spent its entire existence reshaping the landscape, became part of that landscape forever. Today, visitors to the former Muskingum mine site can still see the artificial mountains created by the Silver Spade's operations. The massive spoil piles have been revegetated and now support new ecosystems that never existed before the machine's arrival. The artificial lakes created by mining operations have become habitat for waterfowl and fish. Nature has begun the slow process of reclaiming the landscape that the Silver Spade transformed. But beneath one of those revegetated hills lies the remains of the Silver Spade itself, a 6,400-ton time capsule buried in the earth it once moved. The machine that was once the largest mobile land machine ever built has become an archaeological site, waiting for some future civilization to discover and wonder at the ambitions of the people who built it. The legacy of the Silver Spade extends far beyond the landscape it transformed. The engineering innovations developed for the machine contributed to advances in hydraulic technology, electronic control systems, and material science that continue to benefit society today. The lessons learned from its environmental impact helped shape modern mining regulations and restoration techniques. But perhaps, most importantly, the Silver Spade serves as a reminder of both the potential and the perils of human ambition. The machine represented the pinnacle of 1960s engineering achievement, proof that with enough determination and ingenuity, humans could build machines of almost unimaginable size and capability. It demonstrated that the limits of what was possible were not fixed, but could be pushed ever further through innovation and audacity. At the same time, the Silver Spade story illustrates the unintended consequences of technological progress. The machine that was designed to provide energy security and economic prosperity also caused environmental destruction and social disruption on a massive scale. Its operations transformed not just the physical landscape, but also the relationship between humans and the natural world. The Silver Spade was a product of its time, an era when environmental concerns were secondary to economic growth, when faith in technological progress was unquestioned, and when the idea that natural resources were limitless still seemed plausible. The machine embodied the optimism and ambition of post-war America, the belief that any problem could be solved by building something bigger, stronger, and more powerful than had ever been built before. But the Silver Spade also marked the end of that era. By the time of its retirement in 2006, the world had changed. Environmental awareness had grown, renewable energy sources were becoming competitive with fossil fuels, and the true costs of industrial progress were becoming apparent. The machine that had once been celebrated as the future of mining had become a symbol of an approach to progress that was no longer sustainable. Today, as we face new challenges related to climate change, resource depletion, and environmental degradation, the story of the Silver Spade offers important lessons. It reminds us that technological capability alone is not enough. We must also consider the broader impacts of our innovations on society and the environment. It demonstrates that progress is not always linear, and that what seems like advancement in one era may be seen as a mistake in another. The Silver Spade was many things: an engineering marvel, an environmental disaster, an economic engine, and a symbol of human ambition. But above all, it was a reminder that with great power comes great responsibility, and that the machines we build today will shape the world that future generations inherit. As we stand at the threshold of new technological revolutions, artificial intelligence, genetic engineering, space exploration, the story of the Silver Spade serves as both inspiration and warning. It shows us what humans can achieve when we set our minds to seemingly impossible tasks, but it also reminds us to consider carefully the world we are creating with our innovations. The Silver Spade is gone now, buried beneath the earth it once moved, but its legacy lives on. In the transformed landscape of southeastern Ohio, in the engineering innovations it pioneered, in the environmental regulations it helped inspire, and in the memories of those who witnessed its awesome power, the Silver Spade continues to shape our understanding of what it means to be human in an age of technological possibility. The steel Goliath that once reshaped our planet has become part of the planet itself, a monument to human ambition buried in the earth, waiting for future archaeologists to uncover and wonder at the civilization that could build such a machine, and the wisdom to recognize when it was time to let it rest.